Alright, so this is the last example before we get to applications, which is the hardest case, which is the exponential function. The reason it's hard is because the second derivatives are more difficult. Alright, I'm going to kind of show you how to find the second derivatives using sort of a different technique. Alright, so I've got my e function, e raised to the x squared plus y squared minus, or plus 1. So it's e raised to the unit circle almost, plus 1. Alright, so first I find the critical value. So find my derivative with respect to x. Well, that'd be e to the x squared. Alright, chain rule. E to the x squared, y squared plus 1 times 2x. And then g sub y would basically be the exact same expression except the times 2y. Remember, the e term is never 0. And so the only possibility to give me out a 0 is the 2x. Well, that gives me out x equals 0. And the 2y, which gives me out a y equals 0. And so there's only one critical point. And it's the 0, 0. Now I have to figure out if the critical point is a max, min, or saddle. Alright, so the critical point isn't the hard part. The hard part is the second derivative. So remember the d-test is I find the second derivative with respect to each variable. So gxx, gyy, and then the mixed squared. And so in this case, because of the e term, it's actually easier to find. Remember, we actually plug the 0 in. So it'd be the second derivative with respect to x at 0, 0 times the second derivative with respect to y at 0, 0 minus the mixed derivative, and I forgot to square it, at 0, 0 squared. And so I'm actually going to find the second derivatives and plug the 0, 0 in. Because if I don't, if I just plug it in the entire expression with the second derivative, it gets really, really, really messy. And so this is what I'm going to do in this case, because the second derivatives are really messy. Alright, so first, the second derivative with respect to x. Alright, requires, the reason why they get messy is because this requires the product rule. Right, first function is the e, the second function is the 2x. So I get e times the derivative of 2x, which is 2, plus the 2x times the e derivative, which gives me out another 2x. Right, because it's the e times the derivative of the inside again, which is 2x. So I get e, the e term, times 2, plus 2x, e times another 2x. Alright, so it's easier at this point, instead of even simplifying, to go, especially since we have the point 0 zone. We do try to give you points that are fairly nice. The book doesn't always do that, but I do try to give you points that are fairly nice. And so when we plug 0, 0 into this, alright, so I'm plugging 0, 0 into this expression. So we get that zeroes out e to the first, times 2, plus, well, that zeroes out, right, because if I plug 0 in for x, that zeroes out. And so I'm left with a 2e. Right? Now 2e is, you know, an ugly number, but it's still a number, so again, I have 2e. Alright, g sub xy is the next one I'm going to look at. So this one's a little easier because when I take the derivative of this with respect to y, there's only one y part. Alright? It's in the e term. So the 2x comes along as a constant. It's e raised to that x squared, y squared plus 1, and then this time it's times the 2y. Alright, so remember, instead of plugging that into the formula, I'm going to go ahead and find it at my critical value 0, 0. Alright, which is nice because this just zeroes out. So the mixed derivative is just 0. The x-axis is 2e. Alright, now we're ready to do the y. Alright, g of y is that e term. Times 2y. And again, it should make sense. It's going to come out very similar to the x. So g sub y. Well, it's the product rule again. It would be the e term. Times 2. Plus 2y times e raised to that. Times another 2y. Again, just like the e expression, right? It's the first times the derivative of the second, plus the second times the derivative of the first. So you get a very similar expression. when you plug in the 0, 0. Right? This is going to give me e to the first times 2, and that zeroes out. And so g sub y is a 2e as well. And so when I go plug it into my d expression, g sub xx, g sub y minus g sub xy at the 0, 0, I've already plugged the 0, 0 in. This is 2e, this is 2e, this is 0 squared. Well, a positive 2e times another positive 2e is going to stay positive, and so that tells me d comes out positive, so it turns. Well, the xx, g sub xx, comes out 2e, which is positive. That means it turns up. So that tells me the point 0, 0 finds a relative min, right? If it turns up, it's a relative min. And so g 0, 0, whatever that number comes out to be, is a relative minimum. And again, this one's not too bad because it's 0, 0 would be e to the first. So it's just e. Right, and that would be my minimum.